In this video, we're going to take a look at quadrilaterals and specifically trapezoids and kites. So in the first section of our notes, we're going to take a look at properties of an isosceles trapezoid and go over some examples. So for an isosceles trapezoid, we know that they always have one pair of parallel sides. So I wrote that in purple and I drew that in the picture in the same color. So we indicate parallel sides with the little arrows. The legs are congruent, so the legs are in dark green, and I put a little tick mark to show that those are congruent. Base angles are congruent. So in the picture, it's written that base angles are the ones like in the corners. And so notice I have one angle mark for the two at the bottom to indicate that those are congruent, and then two angle marks at the top. Those base angles are also congruent, but not congruent to one another. And then we have diagonals would also be congruent. So I'm going to add that to the picture in orange. So diagonals go across the figure from one vertex to another. And the last property we need to add is that opposite angles are supplementary, or they add up to 180. So opposite angles are like the one in this corner and the one in that corner. So they're like across the figure from each other, and vice versa. So like this one over here in this corner would add up with the one across from it to be 180. So opposite angles are supplementary. All right, so let's take a look at example 1. Finding angle measures in trapezoids. So ABCD is an isosceles trapezoid, and the measure of angle B is given as 102 degrees. And they want us to find the measure of angle A, the measure of angle C, and the measure of angle D. All right, and so if we're just given the measure of angle B, we know that this angle up here at the top is a base angle that would equal the one right beside it, which is angle C. And then we also know that when they are opposite of one another, they're supplementary. So we could say 180 minus the 102 would give us 78 degrees for angle D. And then D is a base angle that goes along with A is also a base angle. They're at the bottom of the figure. This is, let me write this in a different color. These are bases. So this is like base 1 at the top is this segment BC. And you could call it base 2 is at the bottom. So they're base angles A and D. They're not always at the top and the bottom because they can certainly draw this figure like sitting on its side. So you just have to recognize where the parallel sides are, no matter which direction the figure is oriented. But a lot of times it does look like this. So then we could just write everything out. So the measure of angle A was 78 degrees. The measure of angle C was 102 degrees. And the measure of angle D was 78 degrees. Okay, so let's take a look at example 2. In the isosceles trapezoid, the measure of angle S is 70 degrees. Find the measure of angle P, the measure of angle Q, and the measure of angle R. So again, we find our parallel bases, and the base angles are sitting along there. So like we know P would equal angle Q because those are base angles. Then we also know that S, let me just use one angle mark. S would equal angle R. So angle S is 70 degrees. So would angle R equal 70 degrees because they are base angles. And then you could say the ones that are opposite of one another. So like P and R are opposite angles and they would be supplementary. And so 180 minus 70 would just give us 110 degrees. And then that would also equal angle Q because those are base angles. So that is it for example 2. Let's look at example 3. Find PW if XZ equals 18. So XZ is a diagonal of this trapezoid. All right, so that's 18 for the total diagonal. And then PY is equal to 3. So that little part of this diagonal is 3. But we know the diagonals of an isosceles trapezoid are congruent. So that means the missing part of the other diagonal would be 18 minus 3, which is 15. And then that is what they were asking us to figure out. So we could say PW equals 15. All right, so let's take a look at properties of kites. So a kite is defined as a quadrilateral with exactly 2 pairs of congruent consecutive sides. So I've drawn in the picture what that means in the same color as what I wrote. So what I just said is in purple, and over here in the picture it's in purple. So consecutive sides are the sides that are beside each other at the top and the bottom of this picture. And so they're written with 1 purple tick mark at the top. Those sides are congruent. And at the bottom, there's 2 purple tick marks, and those would be congruent. Another property of a kite is that the diagonals are perpendicular, so they form 4 90-degree angles. So let's add that to this picture. They are perpendicular where they intersect, and they would form 4 90-degree angles because of that. Then we have a property that states non-vertex angles are congruent. So I labeled in this picture what the non-vertex angles are considered and what the vertex angles are considered. So if your kite looks like this kite and it's sitting so that sort of the longer diagonal is vertical, those are your vertex angles. But of course they could turn this figure around, so you just want to always look for where that longer diagonal would be. And those are your vertex angles. And then the shorter diagonal are your non-vertex angles. And the non-vertex angles are in red, and they are congruent. So then you can also see that diagonals only bisect the vertex angles. So again, let's look at our picture. The vertex angles are the ones that are T and R in this picture. And that diagonal bisects those angles, so it breaks them into 2 equal angles. So I put little tick marks. At the top, there's 1 tick mark, and at the bottom, each angle has 2 tick marks because they're bisected, but that does not mean that all of those are equal to each other. All right, and the last property we need to know is the diagonal through the non-vertex angles is bisected by the other diagonal. So the shorter diagonal in this picture is the non-vertex diagonal. And we're saying that it is cut in half. So that means these 2 parts of it would be equal to each other. Okay, so let's look at some examples with the properties of kites. In example 1, it wants us to find the measure of angle 1, the measure of angle 2, and the measure of angle 3 in this kite over here. So the measures of the numbered angles. So we know that the diagonals form 90-degree angles. They're perpendicular to one another. So an easy one to start with would be just to say that angle 1 equals 90 degrees. Another important property of kites is that this vertex diagonal, the longer one, bisects these angles that it intersects. And so 32 degrees would also be the measure of angle 3 for that reason. And then this little triangle right here will help us figure out the measure of angle 2. So angle 2, remember that every triangle always adds up to 180 degrees inside. So we already know that angle 1 is 90 degrees, and this angle up here in the corner is 32 degrees. So we could say angle 2 would equal 180 minus 90 minus 32. And so that angle would just be 58 degrees. So angle 2 is 58 degrees. And then we have all that we were looking for. So that's it for that example. Let's look at example 4. We still want to find measure of angle 1, 2, and 3 given this picture. So notice the kite this time is turned on its side. So this means that your vertex angles are actually here on the right and the left. And then the diagonal down the middle, this is your vertex diagonal, which means that it bisects these angles that it intersects. So let me just put 2 tick marks down here to keep my symbols consistent with one another. Okay, so that helps us figure out angle 2 would also be 46 degrees because the one right beside it is 46 degrees. So I'm just going to write that out here to the side. Angle 1 is sitting right at the middle where the diagonals intersect one another and they're perpendicular. So we know that angle 1 is 90 degrees. And then angle 3, we can figure out similar to that last example. You can tell that these angles are part of a triangle. And we know that this one would also be 90 degrees in that corner. And so we could say that angle 3 would equal 180 minus 90 minus 46. So that would just be 44 degrees. All right, so that's it for that example. Let's look at one more example of kites. So it says find the values of the variables for the kite, for example 5. So in this last example, we're going to use the property of kites that states that consecutive sides are equal. That means that these two sides beside each other down here at the bottom are equal, and the two at the top are equal. But you also want to make sure you set up that you have something that has x equal to something with just x. Because for instance, we have to start with the variable we can solve for. And if we start with the two top segments, one has x and one has y, and we won't be able to solve for x or y because we can't isolate the variable. So we're going to start with these two at the bottom. Because they both have x, we'll be able to get the value for x. So let's say 2x plus 4 equals 3x minus 5. I'm just going to subtract 2x from both sides. So I get 4 equals x minus 5. Then add 5 to both sides, so we get x equals 9. And then we can just use that to help figure out the y value, because I can plug x back into this segment up here, and I get 9 plus 6, because x equals 9. So I know that that segment is equal to 15. So then I can say 2y plus 5, which is this segment over here, is equal to 15, and then just solve for y. So let's subtract 5 from both sides, and we get 2y equals 10. And then divide both sides by 2. So we get y equals 5. All right, so that's it for our examples for this video. Thank you for listening.